So I'm going to pop back up the help and go to 1.51, creating the model, and that right away tells us what the joint coordinates are and the way the members are hooked together. So the first joint is at 0, 0 coordinates. You can see it's just separated by space. And the second node or joint is at 0 in x and 15 y. And the third is at 20 as we scoot across and 15 in y. And the fourth is at 20 back down 20 and 0. And the member incidences, member incidence 1, member 1 is connected to 2. The second is 2 is connected to 3, and 3 is connected to 4. Those are the joint numbers at the ends of the members. So you can see how we can follow right along in the help. We're going to add, go to the Add Beam option. The Snap Node Beam dialog box is going to appear, and we're going to trace out our beam. So I'm going to minimize this again so we can do our work. So we're going to set up a grid that will facilitate the work that we're going to do. So the first thing that we're going to do is click the Create to create a new grid. And by the way, this is for a list of grids here. We can have as many as we want. We're going to have it be a linear grid. Notice there are other kinds of grids that you can make, but ours is in a plane frame as a plane, so we're going to do that. We can call it Grid 1 or any convenient name, and say that it is in the XY plane. We need grids to make them even every foot. Let's make it 20 to the right. Remember the spacing, and then we'll make it 15 high, so we'll be right on the outside. And so this is good, and we'll say OK, and that'll create our grid number 1. Check the box. Grid 1 becomes active, and there we are. Our 20 feet across here and 15 feet. So now we can just begin to snap our members and into the location where they go. And you see we're drawing our members, and if you notice over here on the lower right corner, it'll tell us the coordinates where we are at any point. So going to the top, we can see now we're at 15 in y. We'll scoot across, and we'll be at 20 now in x, so this would be 20, 15, and then drop on down to 0, so we're 20, 0. And our frame is geometrically designed. Since we no longer need the grid, we've done it our job completely, we can close the grid out. So now we have our member. By the way, I hit enter after that last one in order to close out. We can see over here our portal file for STAAD.std is the file extension, by the way. We can see where our nodes are, 0, 0, 0, remember that. In fact, all the Z will be 0 since we're working at a 2D frame. Second one is at 0x 15y, then 20, 15, and back down to that. And our member beams, just as we saw in the tutorial, beam 1 goes from node 1 to node 2, beam 2 to node 2 to 3, and so forth. So we're all set, ready to continue. It's a really good idea to save your work as you go along in a complex software like STAAD. So you can either use the little save icon or file save or Control S, the Control key and S, to save your file. Save it. Okay, next we'll want to have our members labeled so we can see what we've got. So right click anywhere on the blank screen, select the word labels. Up comes this big dialog, and let's just do the node numbers and the beam numbers, and apply and say OK, and so we've got it. Node 1, 2, 3, 4, and the 3 members are numbered. So to get our section properties, we can either come up to the icon here at the top for section properties, or we can press the General tab, Property, and notice what pops up over here is the dialog to find that. So we click on our section database that we have. Comes with quite a large database of members. Remember what our vertical beams were wide flange, American. There it is. It's already selected. Slide down to W 12 by 35. There it is. And the ST single section. So click Add, and then that beam is added to our project database. We're extracting data from the overall database. For our beam across the top, remember that was 14 by 34. Add that one, and now we have both of our member types we need in our project database. So close that out. So next we want to associate these member types with these members. So with the one that's selected here, just click. You notice we have Use Cursor to Assign selected. So click on Assign. It says Assigning, and we get this cursor. You notice looks like an I-beam. Gives us a picture of where we are. So take the little arrow associated with it and point at the beam where we wish to use the W14 by 34. So it says, there it is, R2, the reference number 2. So we come back, select the other one. We're still on Cursor to Assign, and click Assign again. Go to the 2 columns and assign the 12 by 35 to that. And then we can turn off assigning, and we've completed that. Once again, we don't want to lose anything, so we'll come up and save our work. If you want to be sure that the materials were recorded along with the sections, we can go back to the section database, open that back up again, and see that, oh yes, when we assigned those beams, we had the material checked, and it was checked as steel, so we'll know that we have the right Young's modulus and Poisson ratio and the like. Occasionally it's important to be able to change working units. You recall we're working in feet units, but in this case our horizontal member here, the length of it is really going to be less than from center to center because of the width of the 2 columns. So we can change working units simply by going to this little icon and clicking on it, or go over to Tools, Set Current Input Unit right here. Let's do that. We'll click on that, and up comes this dialog box where we can switch quickly over to the inch unit, because we're going to be working with some precision now, and say OK. So every unit we now enter will be in inches. In order to input the offsets, first we'll select the beam, then we'll go over and select General Specs. Up comes this dialog where we can specify things. We'll be specifying information about the beam. The dialog comes up. You can see it has all these different tabs here on the top, one of which is Offset. So we can say the Start. Then we'll click Assign to assign that offset to the starting point. And then we can repeat the process. Click on Beam again. Up comes the same dialog. Click on Offset. This time it will be the end of the beam rather than the beginning, and X will be minus 6.0. Coming backwards in the X direction. Add that. After clicking the Assign button, we'll see in the diagram that both ends have been properly offset. Then we can close out the dialogues. Next, we may wish to have a printout of all the information. So we'd want to select all the beams that we have. So move up this time. We could do it several different ways, but move up this time to the select by all, and you can see some of the different methods here. By all beams, and all the beams are selected. Then select commands and pre-analysis print member information. Make sure it's by those selected and click OK. And we'll have a printout of our inputs so far. Then it's a good idea to just deselect the members so the next operation doesn't do something that we wouldn't expect. So just click on the screen anywhere to deselect. Okay, by the way, we're now at section 1.5.8 if you're looking at help or if you've printed that out. And it's time to specify the supports. You recall from the initial picture that one of them, support node 1, is fixed and node 4 is pinned. So to create a support, we need to select the support page, and that's right here, the icon, or as usual we can go to General, Support, and get the support page necessary to create our supports. These specific cursors enable us to use a graphics window or pick for a selected or filtered type of data. So let's go and we'll choose the nodes cursor, and we'll select node number 1. Then we can click the Create button, because we're going to create a support at node number 1. Select the Fixed tab, which probably by default is where it already is, and then click Assign. And you can see now we have a support numbered support 2. This one's just default, and we can see that it's fixed. Next, we'll select with our nodes cursor node 4, click Create, choose Pinned, and assign that. Then we'll close the dialog. Sometimes we'd like to see how our structure looks in 3 dimensions to get a better feel graphically for it, and an easy way to do that is simply right click on the blank screen and then we could either go to 3D rendering or go to the structure diagrams. Let's choose that. Structure diagrams is this big dialog. Let's put it here in the middle so it won't overlap our drawing. You can see here 3D sections. We can show them with no cross-sectional information, or we can do it with full sections, whatever it is we like. Let's do full sections, and we can change the color if we wish. So we'll just click OK on that and see what happens. So there's our 3D diagram, and we can see that at the members, you can see how it's going to be. This horizontal beam is going to be welded, probably joined there, and the columns and so on, sitting on their fixed or pinned footings. We can also get a full 3D rendering at any time. Simply right-click and come down and choose rendering, and it'll render a perspective view of which then can be disposed of as a normal image. To get back to our normal view, as you see here, just simply right-click, go to Structure Diagrams, and click None and OK, and you'll be back to our analytic model